I'm hopeful that I'll be able to share at least a little bit of what I've learned, working with coroutines, and more specifically within Android. So we'll go over to a number of different things as far as like what is Kotlin, specifically how it's used, where it's supported, and some of the high-level benefits and features. On top of that, we'll get into what Kotlin Coroutines are, especially within the context of asynchronous code, how they work, and how you can write your own code using Kotlin Coroutines. And then we'll kind of tie it together with Android, specifically how Kotlin Coroutines are well supported within the Android Jetpack libraries, and more specifically, their support within the KTX libraries. We'll talk about implementing lifecycle-aware coroutines and some of the newest practices for implementing Kotlin coroutines within Android. I was going to talk also about unit testing, but I don't think that we'll necessarily have time, so testing always always gets skipped. So Kotlin is a powerful JVM language that is growing at a ridiculous rate. It's particularly popular for Android development, but it's also popular for server-side development. It has support as well for native and web development. It has quickly shifted from being supported by Google to having first-class support to being preferred by Google for Android development. It has 100% interoperability with Java. It reduces the boilerplate compared to Java code, and yet it's more concise in many ways. It requires explicit nullability of types, allowing for stronger typing and null safety functionality that allows you to write more reliable code. But that isn't all it offers. Among countless other powerful features are extension functions, inline functions, sealed classes, and as I said, countless other things that really I encourage you to research on your own. So we won't dive into the specifics of Kotlin in this talk, but understanding the basic syntax does help in learning coroutines. So coroutines are a language feature in Kotlin. It enables you to write efficient code that handles threading with minimal effort while still being readable to the developer and easy enough to reason about without blocking your main thread. So why do we want asynchronous code? Specifically within Android, long-running tasks on the UI thread are a big issue. Everyone has probably seen an ANR at some point, an application not responding, and that's like the worst possible situation that you want to avoid at all costs. In the context of servers, it'd be like blocking your main event loop, where imagine you have like an HTTP server, and if you block the main event loop, then you cannot receive any requests throughout the time that you're doing your long-running process. So again, in the context of Android, your entire app will freeze, and we want to use coroutines as a solve to that to avoid it completely. So we'll first talk a little bit about some of the existing asynchronous paradigms within Android, some of the existing solves for this issue. But we'll only specifically talk about AsyncTask callbacks and coroutines. Threading is, basic threading is expensive. It's not easy to navigate back to the main thread, and it's really only even a half-decent solution for fire and forget type operations. And then, RX is a completely different way of thinking about programming and architecting your app. And so while Kotlin does provide some of the tools to allow you to take that same approach, we're going to focus more on the conventional, top-down sync blocking, reads like blocking code kind of approach. So, when it comes to the async task, it's obviously a very verbose approach to doing background work and coming back to the main thread, but it's just as expensive as threading. It has lifecycle issues. So if you launch an async task in your activity and then your activity gets destroyed, you're going to leak that process executing in the background. And async task loader does have a semi-sort of fix to this, but it's at the expense of even more code, even less readability, and other basic concepts within Android, such as intent services and everything else. They suffer from the similar verbosity issues. And then on top of that, async task is difficult to test. So to look kind of at how at how we're going to define, use coroutines, I want to first break down using AsyncTask and effectively give you a decent comparison of why coroutines is a better solution. So obviously, when you define a task that, when you come back to the foreground, you want to execute something in, say, your activity, such as you want to get a unicorn. I figure it was apt given the shirt I'm wearing. But let's say you want to get a unicorn and then display it in your activity or fragment or whatever. You're going to define your inner class, inside of your activity of your async task, and then, and I should have said, so the way we're going to do this is the string is going to be the name of the unicorn you want to get, and then you return a type of unicorn. Well, when we go to do it in the background, you can see it's no help from a type perspective. We're given our array of params, but it's on us to assume the call site's going to match what we need. And it's obviously not super nice having to be like, yeah, let's get the first parameter, even though we only want to accept one parameter. Well, anyway, in the background, we call to our dependency, the unicorn API, to get our unicorn with the unicorn's name. And then when we come back to the main thread, we want to display the unicorn. And then obviously, this is what it would look like when you call it inside of your activity somewhere. But we can definitely make this better. So you can see here, we can modify our async task to support a callback so that we can at least maintain some semblance of single responsibility. Because our get unicorn task really shouldn't be aware of our display logic. It should only care about getting the unicorn and returning it to us. So you can see I made just not too many changes, and now we can do that callback. So we break that down a little bit, and you can see when I define the unicorn task, I now take in my callback lambda, which is going to allow me to pass a unicorn to the calling site of the async task. And then you can see at the call site, we pass in the lambda. And with Kotlin, it's a very clean looking, or I should say, the lambda is clean looking, not so much the async task. But we can easily, when we create the task, make our callback to display the unicorn and execute it, obviously. And then as far as how we're going to modify the unicorn task, you can see now we just in the on post execute, which is back on the main thread, we just invoke our callback. But the problem is, this is not very clean. I mean, it's a lot of code to achieve something that sounds relatively simple. We only care about getting our unicorn, doing something else in the main thread. And so on the issue is once you want to do even more complex operations, right? So one callback isn't the worst thing ever. I mean, it could be cleaner, but it's not too bad at this point. But then what if I want to mutate the unicorn before I display it? Okay, and that's still not the worst, but now I want to display the unicorn after I persist it. Okay, we're getting a little bit of nesting going on, but I mean, me personally, if I have a unicorn, I want to ride it, I want to pet it, and I want to feed it. And now you can see it's a bit of a problem. Now, that was obviously a very egregious example, and no one would ever do that. And on top of it, even this you wouldn't necessarily see because visually you're going to break it out into different functions and at least make it a little bit cleaner to work with. But from a debugging perspective, testing, everything, this is a nightmare. That's where Kotlin Coroutines come in. So with this simple code, which reads as if it's synchronous, we are not blocking the main thread. We're mutating our unicorn, persisting it, and displaying it. And it reads just like your synchronous code. But the real question is why? How does this work that allows us to not block the main thread, yet still stay so readable? So you can see under the hood what some of these functions look like. We have our getUnicorn function, mutate, persist. The only difference that you're really seeing is they're marked with the suspend keyword, which from Kotlin's perspective, the way coroutines are implemented is suspend is the only additional keyword added to support coroutines. It's actually, one of the beauties of Kotlin being such a powerful language via extension functions and their really powerful functional programming paradigms that allow us to, with just a tiny little tweak, do so much more. So obviously you're wondering what this suspend cancelable coroutine is and what's happening inside of it. And this is just a wrapper around our async task for now. So you can see we are basically, this function just suspends our coroutine and then resumes the coroutine once the unicorn's task callback completes. And I know that can be a little bit confusing, so I have this nice graphic. What happens is when you first enter the function, you're still on the main thread. Now you suspend your coroutine, which is basically saying you're going to wait until your background execution finishes, come back and tell the coroutine to resume, to continue what it was doing before. And basically, when you think of the way the async task worked, it's kind of the same thing, but you don't have this dotted line, which helps you prevent the need for that callback. So at our call site, it just looks like a blocking call, but really we are going to the background and then effectively switching back right to where we were before and continuing execution without blocking the main thread. But we can do even more, we can achieve so much more with coroutines. Because when you think of the way an async task is designed, it's also difficult to propagate errors. It's difficult to, deal with canceling it canceling your async tasks in an effective way when you want to. So you can see here, with just a couple additions of functions, I can resume with an exception, and I can invoke on cancellation. Now, what these individually do, and actually I'll stay on this one, is now at the call site of getUnicorn, it's going to throw an exception, like a standard try-catch. Nothing fancy, no weird like on-air callback. And then invoke on cancellation, similar thing. If the coroutine that calls the async task, for example, if your coroutine is tied to a lifecycle like your activity or fragment, if your activity or fragment gets destroyed, then invoke on cancellation will happen, the async task will get canceled, and a cancellation exception will be thrown back to the call site. So, So if we look back at this real quick, basically we're just saying getUnicorn, we could wrap that in a try-catch, and we can catch either our illegal state exception for the unicorn name mismatch or a cancellation exception in the case that our calling coroutine is canceled. And I will say you don't typically care about the cancellation exception because this whole coroutine will be canceled. So, but the problem is, as you saw, once I added on to that async task, first I wrapped it in a coroutine. That wasn't too big of a deal. I was just suspend, resume, not too much code going on. But after I added all that other info, it's looking a lot more verbose, a lot more like, is this really better than what we had before with the async tasks and everything else? Well, that's kind of the beauty of coroutines. We talked about basically bridging that gap between your old async tasks and other callback related code, but really the true power of coroutines is how much simpler you can make this code with just a small change. So now, instead of wrapping that async task, we're directly calling our Unicorn API, and all we have to do is this with context dispatchers IO. Now, what this does is basically we're saying in our coroutine, make the switch to the background thread instead of relying on the async task to do that. Execute our blocking getUnicorn call, and then switch back to the main thread once the Lambda finishes.
Sorry, just holler at me if the audio is too bad. I know it's really hot in here. I'm trying to cool it off a little.
Okay. But you can see here, once we make the getUnicorn call in the API, a suspend function, it gets even simpler. Now it's just a pass-through. We don't even care about what thread getUnicorn happens on. It effectively becomes an implementation detail. right? We're pushing that decision down into our dependency because from the API's perspective, the API knows, okay, I need to execute all of my functions in the background. So they're going to do the with context on their own end. And we're depending on them to do that, to handle that for themselves. But where does that launch piece of it come in? You saw when we first switched over to the coroutine call, all of our functions, all of our function calls were wrapped in a launch call. And that's where Coroutine Scopes come in. A coroutine scope is the building block of structured concurrency. It's the parent to children coroutines. So think of it within a view model, right? Every function you call within your view model, every background operation, whatever, it is a child. It is the work owned by your view model. And as soon as the view model is destroyed, you don't want that to continue, right? And so the idea is that coroutine scopes are cancelable. When the view model is destroyed, simply on onClear, we are going to destroy or cancel the scope associated with our view model. And within Android, outside of ViewModel Scope, there's even Lifecycle Scope, which that now means that we can launch coroutines effortlessly in the view model, in the activity, in the fragment, anything that has a lifecycle of any sort, really. And there are ways to manage your own coroutine scopes, like a repo within your data layer might have its own scope, because if you're going to send off an insert call into your database, you may not necessarily want to cancel that when your view model ends. You want that to still continue on. But it helps a lot with preventing the leaking of coroutines and resources, which was obviously a struggle with AsyncTask. So when it comes to ViewModel Coroutines, you can see we have a pretty standard setup where we have our Unicorn API dependency, we have a private immutable live data, and we have a public immutable live data. And our getUnicorn call is going to call our ViewModelScope.launch. And now, once we are in that launch, that lambda of the launch, we are in a coroutine. We can call suspending functions. And so now we're just going to call our Unicorn API getUnicorn and set the value directly. And that's an interesting piece of that. Typically, just to be safe, you'll want to do like post value on a live data. But the beauty of coroutines here is we are in the main thread. We can directly set the value, but when getUnicorn is called, just that one piece happens in the background. And all of that is without lots of verbosity, lots of additional code to say, yeah, I want to be off the main thread. So you can see here that we return a job from this function. And I'm sure you're wondering, like, what does that mean within coroutines? Well, when you launch, your launch call is effectively a background task of some kind. And in specific cases, you may want to await the completion of that. There's a lot, in the case of live data, it's a little different because there's a lot of times where you can fire and forget because it's going to be posted into your live data at some point, at which point your observers can take care of whatever you need. But let's say, for example, you had a pull to refresh scenario, right? I mean, if you were in, say, your fragment, and you called in to get your unicorn, and you wanted to have your little refresh spinner going on while this call completes, then inside of your fragment, you basically just do job.join, so getUnicorn.join, and that's going to guarantee that you don't block the main thread, and you come back to the main thread and you disable your refreshing only in your on refresh listener, so that your observer, right, doesn't need to have that detail of refreshing. The other piece is lifecycle coroutines. The ViewModel scope is what people use the most, but lifecycle scope is where, for example, the pull to refresh scenario comes in. So anywhere within your activities or fragments, you can launch your own coroutines and they are going to be automatically canceled when your lifecycle is destroyed. But the Kotlin Coroutine library gives you even more power. It gives you very lifecycle aware pieces. For example, you can see here I have, when you launch immediately, cancel and destroy. But then you have access to either launch when created or when created inside of your lifecycle scope.launch. And that's going to be some kind of background functionality that happens in onCreate but in onDestroy. Also deleted, but then there's even more. You have when started, that any work that happens in your when started lambda is going to be canceled and stop executing when your onStop is called. And a similar kind of thing with onResume, where once you resume, it'll and onPause is hit, then your work will be canceled. And that makes it very easy to manage all of your background functionality within your UI at least, without having lots of complex code. So it's like I go back to that pull to refresh example. If you were to, in your onCreate, tie into your on pull to refresh listener, then you could do your lifecycle scope.launch. You can call into your ViewModel and get your unicorn and join that job, and then once that join is complete, you can immediately stop the refreshing. So one of the other things one of the reasons I absolutely love coroutines is because I think they really go hand in hand with the solid principles, particularly within the ViewModel. The way I think of it is if you need to do a context switch, you need to switch to a background thread and stop blocking the UI in your ViewModel, then you're probably doing an operation that is too complex to fall within your ViewModel, right? It's something that's going to be expensive. Whether that be, like in some cases, you're directly calling an API and you want to do a with context, with context switch to the background thread, then realistically that API call should probably fall within like a repository, where now in your repository you have a suspend function where you do your with context call instead of doing your with context at the call site. And the other piece of this, the idea of pushing thread knowledge down into your dependencies, is that it makes your code more testable. And the way that this is one of the biggest growing pains that at least I personally experienced as coroutines started being used by more developers at Kroger, is that we were writing tests where effectively we were, arranging and acting, but then we were asserting before our background job completed. This was tricky because we were doing, those with context calls in the ViewModel, and while we can easily, from a testing perspective, manage the main thread and switch it out for the test thread, it was a lot trickier because once they switched to the background, we didn't have control over the background thread pool. And so what we found is that by following this idea of pushing the with context calls into your dependencies, then you are going to have not only cleaner code, but more testable, just easier to read in general. And so, yeah, it really worked out nice. And actually thinking of another example with pushing this down is, because outside of your API call happening in a ViewModel, the other one that comes to mind is, let's say you want to really utilize the language features of Kotlin. Like you have a sealed class representing your state, whether that be like an LCE approach where you have your loading, content, and your error. Basically mapping of, say, your API call data, think of our unicorn. We might have a loading state, our content is going to be the unicorn, and an error might be that illegal state exception where the unicorn names don't match. We basically are saying that we want to map that into a state, and we want to push that into the repository so that we aren't doing our with context in the ViewModel. Yes, sir.
Can you expand a little bit on solid and how it more specifically fits in to the solid principles?
So really, I say solid on the whole, but I would say primarily dependency inversion and single responsibility are key takeaways for what coroutines can do for us. Primarily around the fact that, as I said, when we have like mapping of our API data into the state that we're going to, like the data we're going to be exposing through our live data, that should fall into your repository because or maybe like an intermediate mapper of some kind, because our view model shouldn't, care about how the whole loading content error, like we shouldn't be doing that mapping ourselves. That should be down in our dependency, which goes obviously hand in hand with dependency inversion, where, we're going to be injecting all of our dependencies that we're creating as a result of wanting to avoid the with context calls in our view model. But that really isn't everything there is with Kotlin Coroutines and Android. I've only covered a few pieces of it, and actually I was worried I would be more tight on time, but I see I could have put more in. But there's now, with the Android Dev Summit having happened about a week ago now, they were talking about using what are called coroutine flows in your data layer. So, support inside the room database for returning flows instead of live data. And alternatives to like the single live event use case where you want your view model to, for example, send like navigation events to your view. There's alternatives to that in Kotlin through like channels and other coroutine mechanisms. And then on top of that, there's like coroutine live data builders, which allow you to make really nice live data implementations where instead of having that, private mutable, public immutable, you could build your own live data, which easily enables you to support that LCE pattern I discussed, where you can, emit your loading state, your content, and/or your error. And then I didn't get to talk about testing. So there are a number of different approaches, and actually Android Dev Summit, again, I call back to them. They were just talking about a slightly different way of doing it that I really encourage you guys to look into and kind of learn on your own, because they really were valuable and not very long talks that I think offer a lot of information.
Can you expand a little bit on the testing?
Yeah, so when I was talking about the issue that we were facing at Kroger, specifically, we talked about the job. I'll show you the fact that we're returning this job, and job has a function called join, where basically inside another coroutine you are going to await for getUnicorn to finish. Well, what we found is that a lot of people were not exposing this job, and so what would happen in a test is, for example, if I did a with context call here, then I would have to join the job in a test, but people weren't doing that. And so effectively, once you switch out your main dispatcher, which is available within the Kotlin Coroutine testing library, it's like a very simple, you can call like dispatchers.setMain, and you typically should do that in your setup, and then you need to set it back in your teardown to a test coroutine dispatcher, which again is available in the testing library. And by people not joining that job and not using those, even if they were using those test rules of switching your main dispatcher to effectively your test thread only, then it was running into that issue where people were asserting before their acting was done. By again pushing that with context down, then we're basically enabling the usage of these jobs without having to explicitly join them by changing the dispatcher.
So what other challenges have you run into implementing coroutines? Like, for example, what's the impact on like debugging?
So I will say they're definitely working on improving this within Android Studio, but debugging coroutines can certainly be a bit more challenging. You know, I would say your standard like breakpoints and everything are not going to function as you expect, because now you're talking about coordinating all this background work where you might think, you know, it does read like synchronous code, but again, it is not blocking the thread. It is switching threads, doing all kinds of stuff, and coordinating that within, you know, a debugging setting can be definitely a little bit tricky. And also the call stack can have been, you know, inflated with a lot of different internal coroutine like pieces that you don't really care about from your perspective.
So can you do any communication with coroutine and share memory or that type of thing? How will they run their own main?
So you said shared memory. Like you're saying, how does coroutines work with like the main thread,
Right.
or
can they communicate through?
like are you talking, you know, calling regular blocking functions outside of a coroutine or in a coroutine? Or so it actually works like very seamlessly. If I go back to, hang on, where was this one? Here we go. So you can see here, unicorn API.getUnicorn in this top example is not a suspending function. It's a regular blocking function that you could call from any standard code. And basically, you know, you can call any non-suspending function from a suspending function, but you cannot call a suspending function from a non-suspending function. They provide a lot of different builders for this outside of ViewModel Scope and the Lifecycle Scope. You also have stuff like the global scope, which is not a good idea to use if possible, because it's effectively not tied to anything. So if you launch a coroutine in your global scope, then it's going to exist either until it completes or until the application kills it eventually, like your whole app kills it. But from a coordination perspective, I assume you're also asking about like how dispatchers.main works, how executing on the main thread works. At compile time, the way it actually, the way it actually works is the Kotlin compiler will effectively build a state machine around all of your code that allows you to pass in continuations. So like when we had the suspend cancelable coroutine, what the parameter we have available is our continuation, which is what we use to control the flow of the coroutine. So like we're effectively saying, like at this point, you know, we yield that thread, we yield, for example, the main thread, and then now we tell it explicitly through the continuation, okay, now we're done yielding this. Now block block our main thread again and continue with what you were doing.
So is the scheduler involved in this kind of?
So I don't. So from a dispatchers.main is directly built on the main thread. Dispatchers.io under the hood is a cached thread pool. So the general premise is, hang on, what did I do? So the general premise of dispatchers.io is, imagine you had, you know, 5 threads, all like 5 threads in your cached thread pool, right? And you execute something in dispatchers.io. It's going to block one of those threads. And now, let's say, while that's happening, you have another call that does with context dispatchers.io. It's going to first check, it's going to effectively check that first thread and say, is it blocked? Okay, you know, if it isn't blocked, then continue there. But if it is blocked, now use the second thread or use the third thread. And basically that coordination of the suspend cancelable coroutine, when that resumes, it unblocks those threads. And so, you know, it's automatically coordinated behind the scenes to really make that seamless for the developer. Are there any other questions? Yeah.
What is the relationship between coroutine context
And a scope? So the way that coroutines are built is that anywhere inside a suspending function, whether that be inside like a launch lambda or an actual suspend function, you have access to a coroutine context. Now the context, the primary thing it has a reference to is the job, the overarching like the overarching source of the call. So like when you do launch, right, you're going to immediately create a coroutine context, and every other function that you call in that suspend function is going to pass your coroutine context around. And that's actually how the cancellations work. Effectively, it's on whatever you're calling to constantly check, is the job canceled? If it's canceled, kick back up. But the way that relates to coroutine scope is a coroutine scope is built with a coroutine context and allows you to launch additional jobs off of it. Like I said, it's like, think of the ViewModel example, where any background operations you have going on in your ViewModel are effectively children jobs. They're owned by the ViewModel. And so your ViewModel scope is going to be built off of your application scope. And so the idea is, if the application cancels, then we want to cancel all of our jobs, like every ViewModel, anything. We want to kill the whole thing. And then within the ViewModel, we have our ViewModel scope, and we're saying, okay, it basically cascades, right? The main application dies, we kill we kill all the ViewModel jobs, and we can even define our own special coroutine scopes as well. So I don't have a specific example of it, but one thing that comes to mind is, let's say in this example with getting the unicorn, we were getting the unicorn and we were then doing like that mutate and persist call. Well, maybe we want to asynchronously we want to persist this unicorn, right? And then display the mutated unicorn, but still, persist that one. So what would happen is you're going to do like your regular suspend function call, or I should say, you start by defining your own coroutine scope, which is a function much like suspend cancelable coroutine. It's literally called coroutine scope instead, and you pass in your suspending lambda. And inside of that, you have access to, first off, call and get your unicorn, and then you want to launch and store a reference to that job returned by launch, or in this case, you'd probably want to use async, because async is exactly like launch, but basically you can get a return value instead of just a job that doesn't have a type. But you would use async, and now you're saying, okay, now we're doing parallel work, right? To where we're going to mutate the unicorn asynchronously at the same time that we persist the unicorn, and then display that as soon as possible. And that coordination allows you to do a lot more powerful work with coroutines. I don't know that I answered your question, but
Close.
I was trying to figure out, where did ViewModel scope and Lifecycle scope come from? But it didn't seem like those are variables that you declared.
yes. So
Through interfaces.
So those are made available by the KTX libraries. So I think it's the Lifecycle, like the Jetpack Lifecycle KTX. I think it is what gives you both of those, or it might be ViewModel. I think it's ViewModel KTX for the ViewModel 1 and Lifecycle KTX for Lifecycle Scope. And then similarly, I mentioned like the live data builder functions, and that was made available through live data KTX.
With this, are you able to define where the suspendable functions resume? Are you able to define a thread, like a main thread?
Yeah, you definitely can. So the way that suspend actually works in this case is you're with context. Since you pass in a lambda, you're basically saying, I'm only guaranteeing I'm on the background thread during this lambda. So let's say I call get unicorn from the UI, like from our view model. Remember, that's what we were doing. Basically, when you call the suspend function, it doesn't actually matter where you're coming from. We're just guaranteeing that for this one critical section, we are going to switch to the background thread and then switch back to wherever we were before. So you can call, for example, I could call this from a dispatcher IO coroutine, and when it does with context dispatchers IO, it'll still work. But I could also call it from main. And I've talked a little bit about dispatcher's main, but that is also available. There's a number of dispatchers. Dispatcher's IO and dispatcher's main are probably the two main ones you'll use. Dispatcher's main is the main thread, and I can technically, like if I was doing a background operation in this with context IO, if I was in the view model and I didn't want to do like a post value on my live data, I could technically do with context dispatcher's main and set the value and then switch back to the IO and switch back to the call site. Oh, sorry.
So this type of suspend function, is it just a one-off so you can't monitor it and pull it for it safe it's completed?
Say that one more time.
For this type of suspend function, how do you, is it just a one-off thing so you're not meant to keep a reference to it to cancel it, or do you have to have a different return?
So that's kind of the whole, that's the whole thing with coroutines is that basically just by marking your function with suspend, it's already context aware. It's already aware of where it's being called from, or at least it's tied to the coroutine scope that calls it. So like if, for example, I call from my view model to get unicorn, right, this suspend function. And this is, let's say that's going to take 5 seconds, right? And 3 seconds in, my view model gets destroyed. It's automatically going to cascade that down to this and cancel it for me.
What if you want to dynamically cancel it based off of like user interaction, not necessarily closing the app or going back from the activity or something? They hit cancel like a dialogue. Is there a way to notify that suspend function?
Yeah, so basically you would need to build your own coroutine scope, which isn't actually like too challenging. As I was saying, it's just another builder function, but you can actually define a custom scope as well. So I don't have, again, a specific example of it, but your coroutine scope, it has like a constructor where you can pass in a coroutine context. And in this case, let's say you want to tie it to the view model scope, but you also want to enable yourself to manually cancel this specific piece of the job. Well, you're going to create what's called a supervisor job, which is what most coroutine scopes are built around. A supervisor job is just like the regular jobs we were seeing. Like you remember in the view model, we have get unicorn, return to job from launch. The supervisor job is a job that allows you to spawn additional coroutines to it. So one of the things of the supervisor job is there's a function called cancel children, which effectively doesn't cancel your supervisor but cancels everything that's spawned off of it, right? Well, you take the supervisor job, and when you pass into your coroutine scope constructor, you take ViewModel scope plus, and I mean literally the plus operator in Kotlin, ViewModel scope plus the name of the supervisor job you created, right? And now you can say, like, take that custom scope, right? And you can do like custom scope dot launch, and from custom scope dot launch you can call get unicorn. And then what happens, for example, when your user cancels the action or whatever, you can reference to that supervisor job and call cancel children. And so it will be tied to your view model to where if your view model gets destroyed, it's going to cancel that work. But at the same time, if you manually cancel it, it'll also function for that.
So you can't fine grain it to the child. There's no overload that says cancel child.
For what?
So if you wanted to cancel a specific suspend function, so if you like want a series of them, but you want to cancel one.
So you can't cancel the suspend function directly, but that is where again, like you have that custom scope. Where do I have this at? Hang on. Oh wait, I have further forward. You can't cancel your custom scope, but at that point, you would basically want to launch off of another scope. Because this is your reference that allows you to control canceling a specific job. So you could even store a list of ongoing jobs. And you could easily maintain and say, it could even be like a map structure where you store the ID is your key and then the job is the value. And effectively, you can specifically get a reference to the job you want and cancel it.
Which package is this job object coming from?
So it's from the Kotlin.Coroutines package. So basically the way Coroutines is built, I talked about how the suspend keyword is like the only like full-blown language level thing that they changed. Everything else is built in the Kotlin Coroutines libraries, which are separate dependencies. There's Coroutines core, there's even like, there's RX stuff to kind of bridge that gap. There's an Android specific package. I don't remember what each of them necessarily contains, but basically you pull in the library, the Kotlin Coroutines core library, and this is what would give you access to job.
When you said the view model dies, the coroutine automatically gets canceled. Is that back to the KTX stuff? Or?
Yes, that's the KTX stuff. The Android specific stuff is KTX. There's a couple, like they have the Kotlin Android library, like Coroutine Android library. I don't remember what all pieces it exactly gives you. I think it primarily revolves around testing, but don't quote me on that. Yeah, and really, I will say the Kotlin language, like their website, their language documents are really incredibly helpful. I mean, they tell you everything you want to know, and I really encourage you to look in. If you want to know more about it, they have some very in-depth like descriptions of how everything works, and really help to remedy some of the confusion around it. Any other questions?
Can you like change functions in like RX Java though?
So you can with some mechanisms. Well, the whole point of coroutines though is that this is in essence like chaining your functions, right? Because you're saying wait for get unicorn to finish. It's like a standard synchronous code where you don't need to observe the completion or use a callback for the completion. We're just saying, in essence, this reads like synchronous code, but it's not. And so it is meant to kind of remove the need to move towards that RX like observable pattern. That said, like I was mentioning before, there even is like an RX library to Kotlin Coroutines. I'm not too familiar with it, but they add a lot of functionality to kind of bridge that gap. And I also mentioned Kotlin Coroutine flows, which in some cases are kind of meant to be that competitor to RX.
Like JavaScript?
What's that?
Like similar to like JavaScript? Is that like the flow?
Yeah, the flow would give you that. There's like on complete call this, on start call, like there's a lot of functionality available there.
You can write that without those intermediate variables, right?
Yeah, definitely.
You're referring to Arrow?
What's that?
Are you referring to Arrow?
For
The Kotlin JX? Or
Oh, no, I'm saying there's I believe there is a dependency developed directly by JetBrains that has RX extensions to kind of help.
yeah, it's lightweight.
Yeah, that's kind of their whole premise with coroutines. So, yeah. Anything else? All right. Thank you very much.